Um, I'm not going to go super in depth to the material stuff that I assigned. Like I said, those of you that didn't get a chance to read it, that's now your assignment for this week. I did want to talk real quickly about, we have different material types. They're divided basically into 4 classes, kind of like the 4 Hogwarts houses. Obviously, you can probably read the 4 classes are metals, ceramics, polymers, and composites. Now, without looking at the stuff below, what can you guys tell me, either from what you read or just because you already know some stuff, what are some properties of these different material classes? Start with metals. What are some things you guys know about metals?
They're usually pretty hard.
Okay, hard and shiny. Yeah. Good conducting heat. Okay, do they conduct anything else pretty well? Yep, very good electrical conductors. Okay, anything else? All right, I'm going to ask you, if you were to try to make your rings out of a piece of ceramic or wood or something that was the same size, would it work as well as making it out of coins? Do you know what the name of the property is that metals have that makes that possible to be able to like bend it and form it like that? Okay, that's totally fine. That property is called ductility. Or being ductile. That means that you can bend it without breaking and it retains its shape. Ceramics, what can you guys tell me about ceramics? Yep, they tend to shatter. They are not ductile at all. Ceramics, when it comes to breaking or failing, it's typically all or nothing. They're very hard, so they're very abrasion resistant. In fact, most abrasives, which are things that are used to scratch up other things, the abrasive part is some sort of ceramic. You can also consider most rocks and a lot of natural minerals that are not metals. You can kind of consider them to be ceramics. Even if they're not technically ceramics, they have very similar properties. Polymers. What's a polymer? Okay. Yes, technically there is a slight distinction between the terms, but at this level we don't need to be that technical. You can basically just say, yeah, polymer is a plastic. Or you can think of it as a plastic or a rubber. Technically, there are plastics and there are elastomers, which includes things like natural rubbers and silicone rubbers and stuff like that. Polymers can be natural. There are a lot of natural polymers, but most of the ones that we are familiar with are oil byproducts, mass manufactured plastics that you see everywhere. So what are some properties of polymers? Yes. So some polymers are ductile. There's a lot of polymers with a lot of different properties, but for the most part, most of them would be more of what you would consider elastic or flexible. You know, you bend it and it just bends right back. Which metals can be very good at that too, you know, like springs and things. So basically, when you bend something, there's kind of 3 different things that can happen. One is it breaks, the other is it bounces right back to its original shape. The other is it doesn't break, but it doesn't bounce back to its original shape either. It stays bent. That's called plastic deformation. You don't have to remember that, but that's just what it's called. When it bends back, when it goes back to its original shape, that's called elastic deformation. Like an elastic, it bends right back. Annoyingly, plastics are frequently really good at elastic deformation and also plastic deformation. They tend to do both a lot. Cool. I've talked a lot. Do you guys have any questions? I mean, you guys have been good to just ask your questions. That's great.
What if it's mixed with marking like steel? Would that be a metal or a composite?
That is a good question. So alloys, which are mixes of metal, those would still be classified as metals and not composites. It also kind of depends in what way it's. If it's like they're actually melted together and, you know, it's basically one new material, that would be an alloy. That would be considered a metal still. But if it's like you take a sheet of aluminum and you put it on a sheet of iron or steel or something, but they're like separate and you just attach it together, that's a composite. Composites tend to frequently not have the same material properties throughout, or sometimes they have very directional properties. If you apply a force in one direction, you'll get totally different results than if you apply a force in the same direction. So a great example of that would be wood. Wood is considered a composite. Composites can be natural as well. Wood is a mix of different cellulose fibers and stuff, and it has very directional strength. If you've ever tried to cut a log with an axe, like crossways, it's super hard. But splitting a log, if you're any good at it, is pretty easy because its properties are very directional. So, lastly, we'll go over composites real quick. So composite is just a combination of stuff. Lots of things are composites. Like carbon fiber is a composite of carbon-based filament and resin. And you use those two things, combining their individual properties to get properties that are far better than what they would be alone. Although sometimes better is relative, because it mostly depends on what you're going for. There is no one superior material. It totally depends on the application. It's a lot like in like a heist movie. Your age, you guys probably haven't seen a ton of heist movies. Have you guys seen maybe like Ocean's 11 or Italian Job? Those kind of old. The Bad Guys, animated. Okay. Or this comes from a TV show. There's a lot of things that kind of fall into this category. But typically, you have like these criminal teams, and within the team you have this specialists. Often you have a hacker. You might have a guy who's just like the muscle. Sometimes you have a contortionist whose job is to get into some really tight place, or you have a safecracker, or there's always a leader, a mastermind, a guy who comes up with a plan. This is what materials are like. They all have their role, their time, and their place. If you have someone whose specialty is doing explosives, they're probably not going to be the person that you want if what you need is someone to hack all the traffic lights to turn them all green so you can make your getaway. Does that mean that the explosives expert is bad and like a horrible member of your heist team? No. It means that they might be bad for that application, good for other applications. The same thing is true for material. Might be horrible for one application, great for other applications. Now, some materials do tend to be better than others. Wet toilet paper is not good for many applications, other than maybe like dousing a candle or something. Other things, carbon fiber, titanium, aluminum, these tend to be pretty good materials that are good for a lot of things. Steel, plastics, there's a reason plastics are everywhere. They're pretty good. So, what I want you guys to learn as makers, so you can't make anything unless you have something to make it out of, some sort of medium. And so a very good skill of making is determining what material you should even be making stuff out of. So there are lots of material properties that you might want to think about. First, think about so what am I trying to get it to do? And then you would decide what material properties you want to look at. There's a bajillion of them. I put 30 in here. There's a lot more. So you want to narrow it down to 2, maybe 3 tops. You can't have it be the best at every possible thing. That's just too confusing. That's a mess. You need to figure out what the most important things are for the application that you're doing. So here's just some possible material properties. These are the ones that don't have to do too much with how strong it is. And then there's a whole bunch of other ones that have to do with kind of more strength and that type of properties. So what I want to do real quick is we'll go through and we'll do this together a little bit. We'll talk about what properties might be important. And this isn't the type of thing where there's one right or wrong answer. So, example here, we're selecting a material for a bathroom mirror. So what properties might be important? Well, I put number 1, reflectivity. Obviously, a mirror is useless if it's not reflective. That's its only job. Other properties. Cost, that's often an important one. Why pay more for something that you need to? Other ones that maybe aren't quite as important, but still important. Things like corrosion resistance. Bathrooms can be pretty wet environments, and then bacterial resistance. So some materials are porous. Do you guys know what that means? Okay, what does pore mean? P-O-R-E.
Like a hole.
Hole, yeah, like pores in your skin. So porous means full of holes. Often it means that it would soak up water or maybe allow air to pass through it. But it's not just like a flat, smooth, solid, impermeable surface. So you would not want to use a porous material, like maybe wood, especially unfinished, unpainted wood. It's typically not something you're going to want to use in a bathroom because the germs, the water, it gets all in there and you can't really get it out. You can't just wipe it off because it's in there. So typically for a mirror, you would want something that's non-porous and maybe in other ways good at bacterial resistance. Cool. That's probably more in depth with that than I needed to be, but let's go to the next one. So if you're building a skateboard deck, do you guys know what skateboard deck means? Means the wood part. Well, not necessarily wood. I don't want to limit you in your, right now we're not even trying to think of what material. We're just trying to think what material property. properties would be important. So think about what kind of things a skateboard might go through, and then you can just say what properties you think might be important. Durable, okay?
It springs back to its shape.
Yeah, it's able to handle some elastic deformation. It's elastic, there's a lot of ways you could say it. Durable, that's one that you're going to say for a lot of things. It's best to get a little more specific than that, because there are a lot of ways that things can be strong. There are a lot of ways that things can be weak. There are a lot of ways that things can break. So yeah, totally, you want it to be durable, but you want to think about like specifically in what ways. Being able to handle some bending and springing back, or does it need to be durable as far as like wear resistance? You know, if you're grinding a lot on a concrete curb, if it's made out of something that's softer, like a plastic or an eraser or something, you know, you're just gonna like wear through it pretty quickly, or wear a groove so it makes it snap pretty easily. So you want something that has decent wear resistance. What are some other properties that you might want for a skateboard deck? Resistance to what?
Pressure.
Pressure. Okay.
You gotta be able to stand on it, but you also need to be able to
Yeah. Okay. What are some other properties you might want? Yeah, grippy. Yeah, and that's great. That's not one that I put in like the material property list, nor would I. But it's totally a material property, and one that really matters in this case. Anything else? Have you guys ever seen a skateboard deck built out of steel? Tungsten.
Too heavy.
Too heavy. Okay, so you probably want it to be lightweight. Because you gotta be able to kick it around, pick it up, carry it. You don't want something super heavy. Cool. So those would be some things for a skateboard deck. And then if you're choosing those properties, you might then be like, okay, what are my most important ones? So for example, you might be like, okay, my most important ones are I want it to be light, and I want it to be able to handle a lot of bending force without snapping. So if you chose those properties, then you would go and try to be like, okay, well, what materials would do this? Wood's not bad, carbon fiber, but you probably don't just like know these things off the top of your head, right? So that's where we're going to move on to the next step of, once you've decided these are my most important properties, how do you find something that matches those properties? Anyone want to read what it says for me in the big red box? Yeah. So when it comes to things like material properties, there's so many materials out there. Every material has 50 different properties. As you gain experience with making and just interacting with the world, you'll become familiar with some of these things. Or you can be like, okay, well, what is it normally made out of? That's a good place to start. But also, there's a lot of stuff you just don't know. There's new materials being developed every day. There's a lot of stuff you just don't know. But the internet's good for that stuff. It's good for holding on to a lot of information, and that's what it does. So there are a couple of ways that you can do this. Here's the old school way that I learned in college. You can look up what's called an Ashby chart. That's the old school way to do it. There's a lot of good things that can come of that, but far easier now. And the way that I would recommend generally is to use AI. How familiar are you guys with AI? Did you use it for anything? Okay, so this tends to be a bit of morally gray area for different people of like, when is it okay to use AI? Is AI always evil? Is it always great? Are there times when it's good? Are there times I should use it? I think this is a time when it's perfectly great to use. Should you use it on a test? No, not unless, specifically it's a test that you're allowed to use AI on. But if you're just trying to make something and you're trying to figure out what would be a good material for this, yeah, totally use AI. Especially for a lot of things like adhesives can be really weird. Because some adhesives work really well with some materials and not with others, especially if you're gluing two totally different materials together. Then you'd be like, okay, you're basically trying to figure out the Venn diagram of like, what are the adhesives that work well for this material, and what are the adhesives that work well for this one, and what works well for both. You could do a lot of research. You could scrub Reddit forums for forever, or you could just go onto ChatGPT or Grok or whatever, and just be like, hey, what's something good for gluing leather to plastic? Whether or not to use AI does somewhat come down to personal philosophies, whatever. But it is a very big, very useful tool that is not going anywhere. I think if I had talked about, using AI to anybody like a year and a half ago, 2 years ago, they'd just been like, what is that? But obviously now it's in everybody's vocabulary, it's everywhere. It's not going anywhere. So my recommendation is to learn how to use it in good ways. It is good at a lot of things. It is really bad at a lot of things. Figure out what it's good at. But When it's something that's like comparing databases of properties and like material data sheets and stuff, that's not a human thing. That's a computer thing. Let a computer do that. So I wanted to show you guys, this is a real conversation I had with ChatGPT a couple of months back where I was working on developing a kit that is called the Bottle Blaster. It has like a bottle rocket thing. Anyway, there's a 3D printed plastic like rocket nozzle that screws onto a soda bottle. And I was trying to decide what material would be the best to get to do this.
Because we've tried making this before, it was just hard to, get it to where it didn't break quite so much.
Yeah, and where it normally broke was when the whole thing would hit the ground after being shot. Like if the nozzle hit on concrete or asphalt, it pretty much would break almost every time. So I identified the material property I was concerned about was impact resistance. The other kind of material property that's a little more hidden here is I needed it to be something 3D printable. There's going to be some technical jargon in here because I wasn't making this for you guys. This was just a conversation I was having. But there are two types of 3D printing. One's called FDM, the other's called SLA. That's all you need to know about that. So I asked that. So I needed impact resistance, and I needed it to be a material that is 3D printable. So then it gave me some answers. And then these are some answers for the other type of 3D printing, and gave me tons of useful information. And then I was like, okay, cool. Well, I'm going to tell you some of the other things that are going to try to make it break. Like it's going to be under garden hose pressure. Water can be really harsh to some materials. Ultraviolet light is really harsh to most materials. A lot of materials, especially polymers, don't do particularly well in the sun. And so I was like, oh, okay, well, you need something pretty specific. And then it told me, hey, you should use ASA. I ordered some ASA filament, and I printed the things out of ASA, and they worked a lot better than what I was using before. I did destructive testing with it and other things.
So sure, we could have spent 3 hours researching on Google all of these different sites and these different materials, or hey, AI is really good at scanning a lot of different sources very, very fast.
Yeah, this is kind of how it works. So we're going to do another quick activity. So now we're going to use ChatGPT real quick. We're going to ask it some questions, but we're going to need a scenario. So what's something that one of you guys wants to build? We'll build a sword. Okay. What's the purpose of it? So would it be for battle? Would it be for looking cool on a wall? Would it be for LARPing, like live action roleplay, so where you are kind of using it but not to like actually hurt people?
It would be for use so that I can learn how to use a proper sword.
Okay.
Awesome.
Cool.
So then, like, the appropriate weight would probably be important, so that you could get used to moving with that kind of weight.
All right. So
Dimensions.
yeah. So there's a couple of ways we could go about this. One is we could try to identify what properties we think would be important. So yeah, you would maybe want it to be lightweight. Obviously, a sword you would want it to be out of a very hard metal. You wouldn't want to make a sword out of aluminum or silver or gold or something. They're very soft. So if you hit it up against anything, that it would lose its edge and get nicks in it. So you'd want to make it out of a hard metal. But you might be like, well, I don't exactly have a blacksmith forge in my backyard, so how would I go about doing this? So you might ask that, and then you'd get an answer. Granted, a sword is something that's pretty hard to make without specialized metalworking tools. And it might give you an answer and be like, okay, obviously it doesn't really understand what I'm going for yet. I didn't give it enough information. Okay, for functional blades, mild steel flat bar. You can get that at most hardware stores. It can be cut, ground, and shaped. Cool. But it won't hold a great edge. Spring steel, which I believe actually is very, very popular for hobbyists and people that do make swords or armor or that type of thing, because it has a lot of the properties you want. And you can actually get it relatively cheap or free, because you can just get it from a junkyard off an old truck or something. Cool. And then you could ask some follow-up questions. Like, maybe I want to use something that's already kind of a blade, it's already got an edge. What would be some good things I could use there? And like, oh, well, you could maybe get a machete or lawnmower blades or something. Anyway, and then you could do that, and it tells you useful answers. Will it give you 100% correct answers all the time? No. Sometimes it'll give you answers that are totally wrong or it'll contradict itself. It's not perfect. But
And that's why the follow-up questions.
it's also why it's good to take classes like this so that you have some background knowledge so that when it's saying stuff, it's like, that doesn't sound right. Or so that when it's using terms like hardened, tempered, things like that, you know what that even means, impact resistant. It's also really good to just make stuff, do things, interact with it so that you're just familiar with the properties yourself, just from a, hey, I've kind of done something similar to that before kind of way.
Actually, properties and tell you the closest material.
Yeah, so
So what's a property that you're seeing up here that you're just like, hey, what's a material like that?
Let's go with like dense, cheap, and ductile.
okay. Now in this case, it's going to take into account your previous question. So you'd either have to tell it, hey, forget the sword thing, or you can just start a new chat. But it thinks we're still talking about swords. Maybe we are. I don't know. It would what context your question was.
It's something to remember. If you want it to not take the last question into account, you need to tell it so.
It'll tell you those kind of things, and then you can be like, okay, which of these can I find at Home Depot? But anyway, it's a tool. Like any tool, it can be used for good, it can be used for bad. Use it for good, learn how to use it well. At least that's my recommendation. So the situation is, you're deciding you want to try to make some cash on the side by selling things on eBay. You found some things that you can get for $5, and you notice that they go for $15 on eBay. So that seems like, hey, I can buy it for $5, sell it for $15. Woohoo, $10 profit. Except that $15 is free shipping because no one likes to pay for shipping. But shipping is never free. It has to get paid for in one way or another. So you as the seller who are offering the free shipping, you've got to figure out a way to pay for all that. You want to keep your costs as low as possible so you can make as much money as you can off this sale. But you also need the thing to not arrive broken. So you have to not only worry about how you're shipping it, as far as like, you're doing FedEx or UPS or whatever, but also how are you packaging it so that it doesn't get broken on the way. So we are going to do that. Just the thing that you guys are going to be shipping is an egg. We're all going to be shipping them in the same boxes. Your job is to figure out how to protect the egg inside of that box so that it doesn't break. So this is pretty similar to like an egg drop type thing. But we're not only worried about how to protect the egg the best, we're also worried about using things that don't cost a ton of money because you're trying to make money selling this egg, and you don't want it to be super heavy because then your shipping costs go up and up. So we're gonna do this. I tried to set stuff up with as accurate of costs as possible. So we have associated with a whole bunch of different materials. I don't even have all these materials here. These are just things that people might have or could use as options. I've got a lot of them here. Associated costs. So you don't want to use any more than necessary because that'll cut into your profit. Here are the actual shipping costs for sending something of this size and shape via USPS ground advantage shipping. So anything from 4 to 8 ounces costs the same, but if you go over those 8 ounces, then it costs almost $1 more to ship it. And then if you go over 12 ounces, it costs almost $1 more. If you go over a pound, well, don't go over a pound because then you're paying more in shipping than what you're going to be making for yourself. And the other thing to consider is, does it break? But this isn't necessarily completely a black and white thing because you can't just design every package that you're sending to just be able to withstand everything. Packages get run over by forklifts all the time. It's going to break if that happens. Like, don't even try to make it withstand the weight of a forklift. Just hope that doesn't happen very often. Most of the times that does happen, the carrier will refund you because that was totally their fault. But other things might happen that might break your stuff, but they're pretty rare. And so you might decide, like, maybe I'm okay if every once in a while something arrives broken and I have to refund that order. That might be better than spending a lot of money making every single one package super well. That's everything in the real world, which is what we're trying to do, is learn all these concepts about how they apply in the real world. Everything in the real world is about finding the best balance. And typically the people that get paid a lot of money That's often kind of what their job is, finding the balance of what the best thing would be, whatever field and type of thing that they do. So how this will work is we're going to do stuff, and then we will test and see under what conditions your egg breaks. We'll keep track of how much material you used, so we know what your material costs were. We'll weigh it to see how much it's going to cost to ship it, and then at the end of all this, you'll get a score of your profit per sale.